Welcome, everybody. I'm Mariquita Solis with We Did It Health, and I'm excited today to bring Dr. Camila Perussello here to talk about food additives. At We Did It Health, we really encourage whole food, plant-based eating to deal with chronic diseases in prevention and in treatment. And so we're very lucky, and blessed to have Dr. Camila here, who's going to give us the inside scoop as a food engineer on how we can do better, how we can be more aware of what's in our food and take better care of our health. So welcome, Dr. Camila.
Thank you, Mariquita, and hello, everybody. Thank you for joining us for our episode number 4 of this 6-part series about how food is produced and how it affects our health. So let me share my screen now. I think you have to enable me, Mariquita.
All right. Give me 1 second here.
No problem.
Okay.
Just a second. Right. Can you see the slideshow?
Yes.
And can you see me okay?
I can see you.
Okay, perfect. So today we will talk about food additives, which is a topic of concern in most consumers' minds. But before we start, let's have a look at our series overview to situate you where we are, and especially those who haven't watched the previous episodes. So in episode number 1, introduction, we discussed how our food habits have changed with time, how food technology helps us feed a growing population, and what food engineers really do. And I also shared with you a little bit of my career journey. In episode 2, we explained why plant-based eating is at the core of a healthy, peaceful, and sustainable lifestyle. I also gave you valuable tips on how to make the most of your food choices and how to easily transition to a whole food plant-based diet. And finally, in episode 3, we talked about food processing and health. Many people associate the word processing or processed food with something negative. And this is factually inaccurate. Cooking is a form of processing, for example. There are many great reasons to process food, for example, food safety, food diversity, and nutrient absorption. We also discussed when processed foods should be avoided and why, focusing on ultra-processed foods with low nutritional value. Also in episode 3, we cleared many misconceptions about the health impact of both processed and unprocessed foods. So if you're interested, please watch the previous episodes on We Did It Health YouTube channel. And today in episode 4, we will talk about why additives are used in food production and how to avoid them if you are concerned about your additive intake. And before I give more details, let me start saying that food additives are substances added to food to make it look, taste, and smell better, to make it safer, or to extend its shelf life. Now, when you think about food additives, what picture do you have in your mind? I believe many, if not most people, imagine something like this: chemical substances made in a lab with long names and that are probably harmful to your health. However, most people would not think of everyday ingredients such as table salt and sugar as additives, but salt and sugar are actually 2 of the most widely used food additives. Salt, for example, has been used for centuries for food preservation. And then you might be saying, okay, but salt and sugar are not healthy anyway, which I agree, of course. The regular consumption of salt and sugar should be avoided. But what if I told you that herbs and spices are also common additives? For example, paprika, black pepper, and rosemary leaves are used to make food more appealing and also to extend its shelf life. Other ingredients from plants are also additives, like beetroot powder to improve the color and garlic extract as an antioxidant. Also, many isolated chemical compounds found in nature are used as food additives, such as citric acid and ascorbic acid, also known as vitamin C. And these substances are found in citrus fruits. And then, of course, some additives are chemical compounds synthesized in a lab. Now, I know that the word chemical frequently evokes negative associations, but it's important to remember that all components of our food, all plants, our bodies, and literally the whole world around us are made of chemicals. Even things like water are chemical compounds. Plus, the fact that something was made in a lab doesn't make it more or less safe than a naturally occurring substance. There's no straightforward relationship between the source and safety of a substance. I'll give more details later, but let's keep that information in mind. Additives are classified into three main groups according to their source. Natural additives come from plants, animals, and minerals. For example, natural vanilla extract or vanillin is used to improve the flavor of food and beverages. We also have nature identical additives, which mimic natural compounds, meaning they are copies of substances that exist in nature. An example of a nature identical additive is ethyl acetate, which is used to give a sweet flavor to different products. It's not a sweetener, it gives actually a fruity flavor. And finally, we have artificial additives which do not occur in nature, like ethyl maltol to enhance the taste and smell of food and beverages, like ice cream and fruit juice. But here's an important thing to remember. No matter the origin, all additives must undergo safety tests to ensure they are safe for consumption. And to understand why food additives are so widely used in the food industry, it might be helpful to think of how certain foods became known to humans. Have you ever wondered how specific foods were discovered? I'm not talking about native edible plants discovered by accident or crops domesticated throughout the centuries. I'm talking about things like popcorn, cheese, and bread. Popcorn, for example. There are different versions of how popcorn was discovered, but the oldest known reference to the plant given origin to popcorn dates around 9,000 years back in Central America and the region that is now Mexico. The plant was obviously different from the corn or maize we know now. It was a type of wild corn known as teosinte, named after the Taino people who were the first to cultivate the plant. Then, over time, selective breeding modified teosinte into modern corn. And the Mayas, one of the major civilizations in Central America, were the first to register popcorn in writing, calling it exploding corn. There is also fossil evidence showing that popcorn was consumed in Peru nearly 7,000 years ago. And there are many theories about how popcorn consumption started, but one of them is that ancient people used the kernels as offerings in spiritual rituals and ceremonies where fires were common. So most probably popcorn was discovered by accident in the sort of ritual. Other food products like cheese, yogurt, and bread were also discovered by accident, mostly as a product of fermentation. Of course, people didn't know back then what fermentation was, and it actually took us centuries to master the process. And quite frankly, we are every year discovering new and better ways to use fermentation in food production and other industries. And by the way, in episode number 6, we will talk about precision fermentation. But anyway, the earliest evidence of bread making dates back more than 14,000 years ago in a desert in Jordan. And only a long time after that, around 10,000 before Christ, with the spread of agriculture, grains became the foundation of bread making. It's obvious to us now, but any dough left to rest leavens naturally because microorganisms, including yeast and yeast spores, are widespread in the environment, including in the air and on the surface of cereal grains. That's why fermentation was used for thousands of years before we understood the concept of microbiology. Let me give you another example, cured meat. Apart from the ethical issue of eating animals in 2023, when we don't need animals to meet our nutritional needs, cured meats like ham and salami were invented as a means of preservation. For obvious reasons, if animal flesh is left out in the air, it will spoil. We now know that animal tissues are prone to different forms of deterioration, especially bacterial growth and fat oxidation. That's why they become rancid, they change color, and eventually become inedible. But centuries ago, people didn't know the underlying mechanisms of food deterioration. However, they realized that adding salt to meat slowed down deterioration rates, especially in combination with cooking. And over time, different salts other than table salt, which is sodium chloride, as well as other ingredients and processing methods were discovered and applied to animal muscle and organs, giving rise to the great variety of processed meats we have nowadays. With the advent of food engineering and technology, we obviously no longer rely on guessing and hoping for the best to make food. This is not safe and certainly not efficient, both from the engineering and economic point of view. We now have a good understanding of the role of ingredients, environmental factors, chemical substances, and food processing methods, and how we can use them to create a variety of food products and beverages that are appealing to our senses. And much of the industry's effort focuses on preserving or improving the quality and safety of food until it reaches the supermarket shelves, which may or may not include additives. According to the World Health Organization, food additives are substances added to food to maintain or improve the safety, freshness, taste, texture, or appearance of food. Food additives have been used for centuries for preservation, for example, sugar in jam and salt in sausages and bacon. Internationally, the health risk of food additives is evaluated by the World Health Organization and the Food and Agriculture Organization of the United Nations, or FAO. Those risk assessments are conducted by an independent international expert scientific group called the Joint FAO-WHO Expert Committee on Food Additives. This means that only food additives that have undergone a safety assessment and are found safe within specified limits can be used. And this applies whether food additives come from a natural source or they are synthetic. We know that food legislation varies from country to country, with some being more flexible than others. This is because national authorities approve the use of food additives at particular levels for specific foods, either based on the International Expert Committee assessment or a national assessment, sometimes even both. Thousands of food additives have been discovered or developed over time to meet the needs of global food production. Many additives could be eliminated if we were willing to grow and harvest our own food and spend many hours per week grinding ingredients, cooking, canning, and preparing food before it spoils. But most consumers rely on the convenience and benefits the additives provide. So additives are sometimes needed to ensure processed food remains safe and in good condition from the farm or factory during transportation to warehouses, stores, and supermarkets, and finally to restaurants and households. But this doesn't mean that all processed foods contain additives. Think of dried lentils, for example. They do undergo actually any kind of legume, lentils, beans, and chickpeas, for example, undergo a series of processing stages between being harvested and reaching our plate, which by definition means they are processed. For example, they are dried under specific conditions for conservation and safety purposes, but they do not contain additives. So before we continue talking about additives, let's discuss food processing very briefly, just to recap some important things we discussed in the previous episodes and make sure we are all on the same page. The word processing has been seriously misused. As everyone eats food, many people think they know how food is produced and the connection with human health, even if they have never read a scientific paper. And especially in this era of information overload, there is a lot of hearsay, misconceptions, bias, and even outright wrong information out there. But the truth is that global food production involves a wealth of knowledge, expertise, and technology. Food engineering, for example, is one of the most multidisciplinary fields in engineering, involving robust knowledge in physics, biochemistry, mathematics, microbiology, and other areas. Food engineers, for example, know what is happening at the molecular level of food, all the way from field to fork and inside our bodies too. And they understand the underlying mechanisms involved in food transformation during processing. But when we talk about food processing or food engineering, for some reason, many people immediately think of artificial, genetically modified, or nutritionally poor food made with low-cost ingredients and harmful chemicals. This couldn't be further from the truth. First of all, genetic modification is not even the job of food engineers. It's more on the side of plant biology, agricultural sciences, and veterinary sciences. Apart from that, there is obviously a whole lot of unhealthy food out there. In the US and the UK, for example, up to 60% of the calorie intake comes from ultra-processed foods that are calorie dense and nutritionally poor. However, we cannot lump all processed foods together because different foods have a completely different nutritional profile. All the products you see in the images are processed before consumption. But of course, the purpose and type of processing vary. Olives, for example, are fermented to become edible. You cannot just eat olives straight from the tree. Almond flour, wheat flour, or really any kind of flour, they all undergo a series of processing steps from the raw material to the end product. Tomato sauce, pickles, and dried fruits, for example, are also processed. They have been transformed into something else compared to the raw material. And the vast majority of animal products are processed, especially for safety reasons, to reduce the risk of foodborne illness. Cashew nuts, jelly beans, and soda are all processed foods, but made with completely different ingredients, using different technologies, and therefore having totally different nutritional profiles. So processing is not inherently good or bad. It's a tool. Using a simple analogy, it's like a knife. You can use it to prepare healthy food or to harm someone. And this is a very important message. The use of additives is not the only or even the main factor influencing the health impact of a food or beverage. For example, meat products like sausages and bacon, which are cured or smoked, are linked to cancer, especially bowel cancer. And this conclusion is based on hundreds of long-term studies, which were summarized in a report by the World Health Organization and the International Agency for Research on Cancer in 2015. The relationship between processed meat and cancer is due to different reasons. One of them being the combination of curing salts with heat and also the natural components of meat. For instance, nitrates and nitrites are curing salts used to prevent botulism, for example, and other foodborne diseases. These additives also delay spoiling rates and improve color and taste. However, the combination between heat and these salts forms carcinogenic substances called N-nitrosyl compounds. That's why regulatory agencies have been reassessing the use of these additives based on current exposure levels, and also many companies have been using alternative additives. However, unprocessed meats also pose major risks because other carcinogenic compounds form during cooking. For example, polycyclic aromatic hydrocarbons. Not to mention that meat is proven by research to cause negative effects on our gut microbiota, leading to chronic inflammation and an increased risk of cancer and other diseases. Also, given the high content of saturated fats and cholesterol, animal products are linked to heart disease, stroke, obesity, and so on. So my point here is curing salts in meat should not be the central or only concern in meat consumption. So here's a takeaway message. In general, the health impact of food is much more related to the natural compounds in the raw ingredients than to the processing stages or the food additives. And just to be clear, this doesn't mean whatsoever that I'm encouraging the consumption of food full of additives. On the contrary, personally, I follow a whole food plant-based diet with loads of natural healthy foods. I strive to buy local, and I even grow my own fruit and veggie. Okay, so my approach is always to eat healthy and inspire others to do the same based on scientific evidence. Having said that, the use of food additives is only justified when it does not mislead consumers, and their application has a technological need. For example, to preserve the nutritional quality or enhance the stability of the food. So additives are added intentionally to food to perform a certain job, which consumers often take for granted. For example, avoiding the separation of fats in mayonnaise and salad dressing, or improving the consistency of oat milk so it becomes thicker and foamy. Different food and health agencies across the world may group additives slightly differently, but the general idea is that they are split up into different groups according to their main function. So here I am presenting a classification that splits the additives into preservatives, nutritional supplements, flavors, colors, texturing agents, and others. So let's go over each of them briefly. The aim of preservatives is to stop or slow down microbial growth and biochemical reactions, making the product safer for longer and also helping retain the color, smell, and taste. Think of antioxidants, for example, to prevent fat oxidation and rancidity in products rich in fats, such as butter. Then nutritional supplements are used to fortify a product with important nutrients that were either lost during processing or are naturally present in low concentrations. Flavorings are added to food to improve the smell or taste, and these make up the greatest number of additives used in food production. Coloring agents are added to replace colors lost during processing and preparation or to make food look more attractive. Texturing agents refer to various types of additives, including emulsifiers, stabilizers, gelling agents, and thickeners. So they basically help mix ingredients or thicken the product. And all other additives in this list, they are grouped as miscellaneous, for example, enzymes. Enzymes are proteins that trigger or speed up biochemical reactions. They are used for different reasons. For example, to improve the dough in bakery products or to improve curd formation in cheese. And frequently enzymes are additives that don't end up in the final product because they are consumed during the biochemical reaction. Now, if you look at a food label, you'll notice that different additives are frequently associated with different numbers. In the European Union, for example, approved food additives are given a unique number prefixed by the letter E. We call this an E number. We have limited time in this presentation, so I will focus on the European coding system, but I will talk about differences in the safety assessment of food additives among countries later. Now, the E numbers indicate what type of additive it is. In the European Union, colors are assigned an E number from 100 to 199, preservatives are coded as 200s, antioxidants as 300s, and so on. So the E numbers help consumers understand the function of that specific additive. In the United States, the FDA, the Food and Drug Administration, maintains a list of all additives approved for use, but they are not given a number, okay? But in any case, food and beverages must be labeled using the full name of the additives in the US. Now, let's take an example from the picture to understand the function of a given additive according to the E number. The muffin you see in the images contains calcium phosphate as one of the several additives. And the E number, starting with 3, tells us that this additive is used to prevent oxidation of fats. Okay. So let's understand a bit more about additives and labeling. The first thing we need to know is that food manufacturers are mandated by legislation to list ingredients and additives. And an important thing we need to know about ingredients lists is that the order of ingredients matters. Ingredients are listed in descending order, meaning the first ingredient is found in the greatest amount. Additives are usually found in small amounts, only enough to perform a specific job. So that's why additives are usually at the end of the list. This has to do with their concentration in the end product. Before approval, food additives are tested and proven safe for that specific use within determined amounts. And the safety assessments include acute, short-term, and long-term studies. And only after the additives are shown to be safe are they given an E number. And finally, manufacturers must include the E number or alternatively the name of the chemical compound in the ingredient list. Sometimes both are present, but not always. Now, in the label we are looking at now, this is an organic tomato puree packed in a carton. We can see that organic tomato puree is the main ingredient, meaning it is found in the largest quantity. In this case, the company detailed the ingredients inside the main ingredient, which are water, tomato paste, and citric acid. The second main ingredient is organic onions, followed by extra virgin olive oil, sea salt, dried garlic, sugar, spices, and finally citric acid. So in this label, the company didn't include the specific percentages of each ingredient or the E numbers for the additives. But in this case, as the names are in general familiar to everyone, most of us understand that the main additive here, or the only actually, is citric acid. And citric acid is used to control the pH so the product doesn't spoil due to microbial growth. And it also has the right level of acidity to make it taste right. And one thing that I want to point out here is that the fact that citric acid appeared as the last ingredient inside the tomato puree in front of onions doesn't mean there's more citric acid than onions. What the label is saying is that there's more tomato puree than onions, okay? I will give you more examples later. And now comes the big question. Are food additives really safe? As I said before, internationally, the health risk of food additives is assessed by the World Health Organization in cooperation with the FAO. These assessments are based on scientific reviews of all available biochemical, toxicological, and other relevant data on a given additive. And the data required to reach a scientific opinion include mandatory tests. These tests include observations and clinical trials in humans and animals. The tests required by the committee determine how the food additive is absorbed, distributed, and excreted, and the possible harmful effects both in the short and long term. Other state agencies worldwide also assess data on toxicology and safety of food additives. For example, EFSA, the European Food Safety Authority. And EFSA don't actually carry out tests, but they reach scientific opinions based on the careful analysis of a wide range of studies published in the scientific literature about a specific additive with the purpose of informing the European Commission. So basically, national authorities around the world approve the use of a food additive at specified levels for specific foods based on those assessments I mentioned, or a national assessment, or even both. And also important to mention is that the approval or restrictions for the use of an additive vary between countries depending on how the local regulatory authorities interpret the additive's toxicity results and the exposure levels in that part of the world. And here's an important point. Anything can be toxic in a certain dose. For example, caffeine is toxic at a high enough dose, but most people don't consume anywhere near the toxic dose, which would be something like dozens of cups in a day. So in order to determine whether a food additive can be used without posing harmful effects, the acceptable daily intake, or ADI, is established. The ADI is an estimate of the amount of an additive in foods and beverages that can be safely consumed every day over a lifetime without adverse health effects. And this is important. The ADI may change among different population groups, either because the exposure level varies or because certain groups are more vulnerable, like children, pregnant women, and older people. It's also important to mention that science is constantly evolving. So ADI values and scientific conclusions in general are updated continuously as new data arise. As with everything, additives that we thought were safe in the past are not considered safe anymore. Think of how many things we thought were harmless in the past and now seem absurd to us. Smoking, for example. That's what science is here for, to help us make smart decisions based on objective determinations instead of guessing or speculation. EFSA, for example, has been reassessing the safety of all food additives approved for use in the European Union before 2009, based on new data published ever since. And now comes another example of a product containing additives, which is a bar of milk chocolate. Let's interpret the label and discuss some important aspects to understand what the real concern in this type of product should be. Is it the additives or something else? Or maybe all of them combined? So based on the things I explained before, we can see right away that the product contains two main ingredients, milk chocolate and chopped almonds. And the manufacturer splits these two main ingredients into their sub-ingredients. Now, milk chocolate, the main ingredient, is made of sugar, milk, chocolate, cocoa butter, lactose, milk fat, soy lecithin, PGPR, an emulsifier, and vanillin, an artificial flavor. While the chopped almonds were roasted in cocoa butter, sunflower oil, or both. So many people looking at this label would instinctively worry about PGPR, soy lecithin, and artificial flavors, right? Now, let's examine each of them. PGPR is an additive approved in the European Union as additive number E476. PGPR is commonly used as an emulsifier or lubricant in chocolate and chocolate products to reduce the viscosity of the chocolate so it flows more easily during processing. And this facilitates things like flowing inside equipment to increase process efficiency, and also makes it easier to shape a chocolate bar or coat a sweet with a chocolate layer. And like most additives, it's used in tiny amounts, something like 0.5% of the product's weight. Now, the other additive we have here is soy lecithin. Lecithin is a food additive that comes from different sources, one of them being soybeans. It's generally used as an emulsifier, but it also serves as an antioxidant to prevent flavors and nutrient loss. Now, many people are concerned about the fact that it comes from soy. For some reason, there is this bad reputation around soy that is not necessarily backed up by evidence. And one of these worries regards the fact that most soy is genetically modified, and the other relates to the alleged hormonal problems soy could cause. But first of all, if we worry about the genetic modification of soybeans, we shouldn't be eating animal products in the first place, unless they are organic. Approximately 3/4 of all soy used in the world is used to feed farmed animals, and only a tiny fraction of soy is used directly as human food. The rest is used for biodiesel and other products. And for biological reasons, everything an animal eats will concentrate in their tissues and secretions over time. Plus, animals have been selectively bred and genetically modified for decades. So avoiding soy and soy products out of fear of GM crops while eating meat, eggs, and dairy is foolish, quite frankly. And secondly, the fact that soy contains phytoestrogens, estrogens from plants, makes some people think they will mess with your hormones. But this is not substantiated by evidence. Even though the relationship between soy phytoestrogens and human health is not completely elucidated, studies show much more benefits than potential threats. For example, protective effects against breast cancer, health benefits among menopausal and postmenopausal women, and protection against cognitive loss, helping slow down the progression of Alzheimer's disease. So actually, we should be concerned with real estrogen, animal estrogen in our diet. Animal estrogen can cause hormonal imbalance because the estrogen molecule is the same whether we are talking about humans, monkeys, or cows. We are all mammals. So what varies among species is the amount of estrogen. And where is estrogen primarily found in our diet? Milk. Cow's milk is a breast secretion, meaning it is a major source of estrogen. And studies show a link between cow's milk and different hormone-related problems. For example, polycystic ovary syndrome and even some types of cancer. So the general population shouldn't worry much about soy when there are worse things to be concerned about. But going back to soy lecithin, this additive is included in such tiny amounts that it's not something to worry about unless one day studies start to show that even negligible amounts can cause harm. And the third additive here is synthetic vanillin, which is a common flavor in foods, beverages, and beauty products. It has the same chemical structure as natural vanillin found in vanilla beans, and it's used in very small amounts because it has a strong note. And again, the use of this additive is approved by legislation. So To sum up, what we should be really concerned about in this type of product is that, first thing, sugar is the main ingredient. And I don't think I need to explain how bad sugar is for our health. Secondly, milk poses a series of health problems due to the high quantities of saturated fat, cholesterol, hormones, sugars, growth factors, pesticide residues, and veterinary drug residues, not to mention that over 2/3 of the global population are lactose intolerant. And third, the other source of concern here is the nutritional value. We are talking about 380 kilocalories in a bar of 73 grams. And over half of the calories come from fats. We have 24 grams of fat in the product, half of which are saturated fats. We also have 36 grams of sugar. Can you imagine? This is about 3 full tablespoons of sugar. And oh yeah, and before anyone says that this chocolate bar has 15% of calcium, which is true, calcium is present here in a reasonable amount. Calcium is also found in many plant foods like broccoli, beans, and almonds. So at the point in time we are now, in terms of scientific evidence, saying that you need dairy for calcium is as silly as saying you should drink wall paint to hydrate. Of course, wall paint will have water in it, but it also contains a lot of dangerous substances. Same thing with milk. So why take the risk? So to sum up the idea here, very often the last thing you should worry about in a food product is the additive. And let's analyze another product, popcorn. So this is a butter flavored popcorn for microwave, which contains several additives with different functions. The ingredient list includes obviously popcorn, palm oil as the second main ingredient, salt, a mix of natural and artificial milk flavors, rosemary extract, which is a natural preservative that helps slow down oxidation. Then we have another natural preservative, which is ascorbic acid, also known as vitamin C, and 2 other natural colors obtained from plants, annatto extract and paprika extract. So again, in this case, let's check if additives should be the only concern here. Palm oil, for example. Palm oil is rich in saturated fats, and saturated fats are associated with obesity and heart disease. Palm oil is also frequently linked to deforestation and poor working conditions, unless, of course, it is fair trade, which doesn't seem to be the case here. Otherwise, I'm sure the company would have mentioned this to increase consumer trust. And the product also contains milk in the form of milk flavors, which are not specified. And milk has a major environmental footprint and involves extreme animal cruelty. It's one of the most violent industries of all. So why be complicit with this? Okay. Now, going back to nutrition, if we look at the nutrition facts, a serving of 5 cups of popped popcorn has 100 calories, with 25% coming from fats, especially saturated fats. The amount of salt is not very high, but it's not low either, 9% of the maximum recommended daily intake. And then on the good side, the serving offers 3 grams of fibers, or 8% of your daily needs, 2 grams of good fats, unsaturated fats, and a little bit of iron. Now, if we take all this into consideration, including the fact that additives must be proven to be safe before use, are additives the only or the main concern here? So we really have to ask ourselves what the price of taste and convenience is. As long as we buy, industries will produce. It's supply and demand. Plus, we are all adults and most of us can choose what we eat. So let's use this privilege in our favor. We are privileged enough to have food on our plate every day. So why not make mindful choices if we can? Okay. Now, I often hear people say things like, oh, it's crazy the amount of work we have to do to avoid unhealthy food. But is it really? Or is it because we insist on eating things we like or that are more convenient instead of eating the things we know are good for us? If you focus on fruits, vegetables, whole grains, beans, lentils, chickpeas, and other whole plant foods, you have all the nutrients you need for optimal health with a minimal amount of additives, zero cholesterol, low levels of saturated fats, and other potentially harmful substances. And it is amazing the amount of delicious and healthy food we can make from plants, algae, and mushrooms. There are hundreds of thousands of edible plants known to science. So really, the key to a healthy diet is to eat plants in a varied and balanced way and avoid animal foods, salt, and sugar. More and more public health agencies have been issued official statements supporting vegetarian and vegan diets because they prevent and even revert diseases. So I will leave some suggestions for you of books that explain why and how to eat plant-based. Each one of these 3 suggestions is based on hundreds of peer-reviewed studies, and the information is laid out in simple language so everyone can read them regardless of their professional background. So the information is out there so everyone can benefit, okay? And before we finish, there's a couple of things I wanted to point out. While some chemical substances and additives obviously do pose health threats, very frequently concerns related to food additives are not backed up by factual evidence. I will show you 2 cases to illustrate real versus unrelated risks. So, a recent study by the UK Food Standards Agency found that certain additives, certain food colors can increase hyperactivity in children. For example, sunset yellow and tartrazine. So now food and beverages containing any of these 6 colors must carry a warning on the packaging. And also manufacturers are advised to use alternative colors. So this is a case where new studies indicate a risk we were previously unaware of. Now, let me show you another case, which is a case of unrelated risks where people blame additives for symptoms that are caused by other components of the food or even by factors outside their diet. And this is also a case reported by the UK Food Standards Agency. They commissioned a study with people who self-reported sensitivity to aspartame, a sweetener, including headaches, dizziness, and stomach upsets. These people were either given a cereal bar with or without the sweetener, but were not told which bar they had consumed. And the results showed that there was no difference in reported symptoms after eating the bar containing the sweetener compared to the other bar, at least in the short term. And then this triggered a reassessment of the safety of aspartame, which was published by EFSA, concluding that it is safe to consume within certain exposure levels for the general population. And why do I say general population? Because of course there are people who have allergies, sensitivities, and even specific medical conditions. So people suffering from food allergies, intolerances, and certain diseases might want to avoid specific additives. So, and I see that very frequently people confuse allergy and sensitivity or allergy and intolerance. So let me explain. A food allergy involves a strong immune reaction that can be life-threatening, okay? While a food intolerance or sensitivity is a higher sensitivity to a food because you don't break down a certain compound properly. Allergies to food additives are extremely rare, and so are medical conditions such as phenylketonuria. Phenylketonuria is a genetic condition that causes dangerous levels of an amino acid called phenylalanine in the body. So people suffering from this disease must avoid artificial sweeteners that contain this amino acid, for example, aspartame. So that is why federal regulations require that any food or beverage containing this sweetener bears a warning, okay? So if you suspect you are allergic to a food additive, talk to your doctor and take a test. The best tool to evaluate the safety of a substance is science. And every day we come up with new hypotheses, technology evolves, our methods improve, and we are able to polish or update our former conclusions. And the other tool we have as consumers is mindfulness, is prioritize healthy eating over convenience, habit, and tradition. I know many people who say they don't have time to cook while they spend a lot of time on social media. So it's a matter of priorities, prioritizing our health. So what we can really do to minimize our risks is to be mindful of what foods we allow into our homes and our bodies. And as I always say, my mission is to educate people based on scientific evidence so they can make choices in favor of healthy, sustainable, and ethical foods. And we can literally change the world when we know better. So, as I always say, science and mindfulness is the best combination. In the next episode, I will explain in more details how to read and interpret labels, including the different kinds of fats and carbohydrates and the ones you should avoid, the difference between expiry dates, for instance, use by versus best before, the meaning of claims such as sugar-free, organic, free range, and so on. So basically, I will guide you on how to derive the most information possible from a food label to help you make healthy and ethical food choices. Okay, so I hope you enjoyed it, and thank you all for listening.
Thank you, Camila.
Mm-hmm.
We have some questions in the chat. Let's see. So let's see. Fernando is asking, oh, can you close the presentation?
Yes. Let me stop sharing.
Okay.
Perfect.
Let's see. Are there additives allowed in one place but not in the other? For example, accepted in the US but not in the EU? If yes, why?
Yes, that's a great question. And yes, that's true. Some food additives that are used in the US are not allowed in Europe. And the same thing happens with, for example, drugs and hormones given to farmed animals to promote growth or increase milk production. And the main reason for this is simple. It has to do with their scientific approach. So the US focuses on probability, while the European Union considers possibilities of harmful effects of drugs, food additives, and other chemical substances. So this means that the European Union focuses on the likelihood of hazards or side effects of additives, while the EU follows a precautionary approach, meaning they restrict or ban additives not only because of the probability, but also on the mere possibility of something wrong happening. And this difference in scientific approach has resulted in the European Union banning certain additives that are still used in the US. So definitely the EU is more strict when it comes to food legislation. And then another reason is that EFSA, the European Food Safety Authority, reevaluates the safety of food additives based on new evidence very frequently, while the FDA, the Food and Drug Administration, frequently lags behind Europe in reevaluating additives and updating their regulations. So for example, certain chemicals used in the US haven't been reassessed for many, many years, even though toxicology studies have progressed ever since after they were approved for the first time. So that's the reason. It has to do with the scientific approach.
All right, well, here's another question from Colette. How can we know what's included in the word spices?
We actually can't, because when they say spices, the food legislation in most countries doesn't mandate companies to detail what spices they are using. So there's really no way of knowing.
Okay, well, at least we know that. So
yeah.
All right, and then Lori wants to know, where can we find ADI values?
Actually we can find, let me think. Okay, as a researcher, I would find this, for example, on the website of a regulatory agency, for example, FDA in the US, EFSA in Europe. So they have these values. Yeah. But actually, we don't need to know these things, because when regulatory agencies approve an additive, there's a big margin of safety. So, like I said, caffeine, for example, caffeine would be toxic if you would drink unreasonable amounts of coffee. Okay, so the ADI is the recommended intake is, how can I explain this? There's the maximum amount of an additive approved by legislation is much lower than the amount that would cause any side effects in humans. Okay, so we don't need to know this. If it's approved, like, we should all be able to trust legislation. But yeah, I know it's difficult to trust them.
Well, that's good to know. All right, so we have time for one more question. Well, does culture habits also affect how much of an addictive can be tolerated? And for instance, I guess two more really quickly. For instance, given that Japan and US have different food habits, can an additive be used more in one than another?
Yes, they can. Actually, the ADI values are also based on the exposure level of a certain additive. So exposure level would mean, for example, something like, for example, algae. Algae are not consumed as much in the Western world. So the ADI takes into consideration how much the average person would consume of a certain product containing a certain additive.
Okay, so I think that answered, let's see, the question. And so we got Magda saying, I have so many questions. Thank you, Camila. That was very interesting presentation.
Thank you.
And so, yeah, I would encourage people to reach out, because you are, where can we find you? Your website was, can you tell us that again, please?
Yes, my website is camilaperussello.com. It's my name, and my email is hello@camilaperussello.com. So if you have any questions, you can email me, no problem at all.
Okay, great. Yes, because I think we all probably have a whole list of questions.
Yeah, but should I answer this question?
Yeah, go ahead really quickly and answer. And
Okay, yes. So are there alternatives to testing? Yes, there are alternatives. For example, in vitro tests and in silico tests. So the thing is, of course, we have to stop animal testing, not only in the food industry, but all industries for ethical reasons. I mean, animals are not things, they're sentient beings. And not only we do have alternatives, but on top of that, these alternative methods very frequently give more reliable results than animal tests, because of course there are significant differences between animal species. There are even differences between individuals, between humans, let alone between animals of different species. So animals, some animals, anatomies, organ structures, and ways of absorbing a determined substance and excreting this substance are quite similar to ours, but not always. So other species don't necessarily react to a substance the same way a human would. So when we use animals to test the safety of a food additive, for example, we might not be able to properly assess all health risks related to that substance. So like I said, we can use alternatives such as in vitro models, and which are tests using tubes and petri dishes in a laboratory. And we can also use silico tests, which are tests based on computer simulation. So these alternative tests are not only more ethical, but are frequently more reliable than animal testing.
that's great to know. Definitely that there are alternatives that work. We don't have to be hurting poor animals. So
Oh yeah, absolutely.
yes, well, thank you so much for this wonderful presentation. And
Thank
we
you,
look forward. You're welcome. And so, and then 2 weeks, we'll be back here again with the next episode.
Yes, absolutely. Yeah.
And if you're watching on YouTube, please subscribe to We Did It Health, and please definitely check out Dr. Camila's books and her webpage, because we all need this important information so we can live a healthy and peaceful life. We can feel safe in what we're eating.
Yeah, absolutely. Thank you, Marikita. Thank you, everyone, for joining us.
Yes. Thank you, everybody.